मॅडम आवाज येतोय का? अडसू मॅडम. अडसू मॅडम.
मॅडम येतोय आवाज व्यवस्थित आहे, काय अडचण नाही.
येतोय मॅडम आवाज.
ओके ओके थँक्यू. अभय.
फक्त तुम्ही लाईट तुमच्याकडे जरा वाढवा ना. तुम्ही काय झालंय अपोजिटला बसलाय लाईटच्या.
ओके हा ठीक आहे सर, वाढवते सर.
लाईट असला पाहिजे तुमच्या समोर असला पाहिजे.
हम्म
लाईट कडेचे असले तर वाढवून घ्या.
ओके सर. थँक्यू सर. अभय.
हॅलो.
हा
हा
अभय,
मॅडम.
ऐक ना, स्क्रीनशॉट घेशील का तू प्रोग्राम चालू असताना थोडे? मी कुंभार सरांना पण सांगितलंय.
हॅलो
हा
मॅडम.
हा कॉल कर ना.
मोबाईल सगळे दिसणार नाहीत.
ओके, एका वेळी नाही सगळे दिसणार का? बर.
हो, कारण मी मोबाईलवर आहे.
नाही नाही बरं
लॅपटॉप वर
ठीक.
सगळे मिळतील.
कुंभार सर घेतायत, कुंभार सरांना सांगितलंय.
चालेल चालेल घेतो मॅडम.
हो सर.
हा
थँक्यू सर. थँक्यू.
हॅलो मॅडम.
हा मॅडम बोला.
माझा आवाज येतोय क्लिअर?
हो हो येतोय, क्लिअर येतोय, व्यवस्थित येतोय.
स्पीकरची काही गरज नाही ना, हेडफोन लावायची गरज नाहीये?
नाहीये, गरज नाहीये, क्लिअर येतोय.
Hello. Hello.
Hello, sir.
Yes, Dr. Khanna here.
Okay, welcome, sir.
So what time you're starting?
3 o'clock, sir.
Okay. So in the meantime, we will set. Yeah, I want to check whether my PowerPoint is shareable or not.
Yes, sir, it
So-
is shareable. Yes, sir.
So let me check. I am sharing it from here.
1 minute, sir. I will make you.
Yeah. Screen. है ना?
Yes, sir.
Are you able to see it?
Yes, sir. Yes, sir.
Good. So this will be the way I will begin. And should I? Okay. Should I send this email to you also for a backup?
Yes, sir. Yes, sir. That will be a good one, sir.
That will be a better idea.
Yes, sir.
Okay.
Yes.
Let me forward this. So you send me Dagna madam ka email में डाल दूँगा.
Yes, sir. Yes, sir. Dagde madam.
Yeah. Okay.
ओके सर.
Dagde@readfmail.com.
Yes, sir. Yes, correct, sir.
Okay. It is coming there. Just you
Yes.
keep it as a backup.
Okay, okay, sir.
Two.
Hello, sir.
Yes,
Ye-
I have sent it.
Okay, sir.
It
I
will
will
reach
check.
to you.
Okay, sir.
2 minutes, 5 minutes.
Okay, sir. Okay.
Can we see that on the video? Oh, can you see me here? Hello.
Yes, sir.
You can you see me? Hello. Yeah.
Yes, sir.
Good to see.
Yes, sir.
Good. So, for the time being, everybody, how many people are likely online? Maybe 40, 50 students. How many students you believe they will log in? Hello, can you hear me?
Yes, sir.
Yes, sir.
Okay, good. We have to set our system in place. So everybody is in the college or everybody is at home? Am I audible now? I have sent the email. Dagre madam, did you get the email? Hello, Dagre madam.
I think she is not online.
Hello, sir.
Yeah. Did you receive the email?
1 minute, sir.
Yeah, please
I
check.
will-
Yeah, good to see you.
Yes, sir.
Because
Uh,
for backup,
no, sir, I haven't received.
you haven't received. Let's see.
No, sir, I haven't received, sir. Dagde@rediffmail.com,
Ah,
sir.
that is that I've sent.
Uh, no, I haven't received. Sir. नहीं सर नहीं में आया मेल
It went from here. It is showing sent.
Okay,
It's
sir, it
checking
will
your
come,
spam
sir,
mail.
then. It will come.
Yeah.
Yes, sir.
Today at rediffmail.com.
Yes, sir. Dagde at
Yeah, please.
rediffmail.com. No, sir, I haven't received now, but okay, it will come.
I think it takes time.
It,
You check the spam mail.
no, it is not there, sir, in spam. So we'll wait for 1 more minute. It will come. Sir, students are there. You ask about audience, no, sir?
Okay. Yeah. What is the status of the students?
Sir, actually all postgraduate and undergraduate students will join. Even senior and junior, both students will join, sir. Senior faculty and junior also.
So at the moment I can see. At the moment I can see lot of people are already.
No, sir, students will join on YouTube, sir. Students will join on YouTube and only faculty will join on the Zoom link.
Are they? Is it going to be a recorded?
Yes, sir.
Is it going to be a recorded?
Yes, sir, it will be recorded.
Huh?
Yes, sir.
So let me.
Students will join from YouTube link, sir. And faculty will join from Zoom link.
Little bit.
Good afternoon, Khanna sir.
Good afternoon.
Good afternoon. Very welcome to you.
Nice to see you.
For a long day, there is a wait. Yes, yes.
Yeah.
Okay, this is 3 o'clock. Madam, we can start now. Shall we start?
Shall we start, sir?
Yes, yes. we can
Yeah,
start.
I'm okay.
Yes, sir is ready. Yes, okay.
Okay, sir. Arsu, ma'am.
Okay. Good afternoon, one and all. I am Dr. Vaishali Adsul from Department of Chemistry. It is my great privilege to welcome you all in the celebration of National Science Day 2021 on behalf of Department of Chemistry, Yashwantrao Moite College, Bharati Vidyapeeth, deemed to be University, Pune, India. Honorable Dr. S.R. Patil, sir, in charge principal, Professor P.K. Khanna, a renowned scientist, uh, Honorable Speaker, Professor P.K. Khanna, a renowned scientist from Defense Institute of Advanced Technology, Pune, Dr. A.B. Pawar, head the Department of Chemistry, Dr. S.P. Dagde, convener of today's program, Adsul sir, Vice Principal of Junior College, my colleagues and my dear students. Many Indian scientists have gathered global recognition by their work, and Indian physicist Sir Chandrasekhar Venkat Raman is one of them. Sir C.V. Raman invented the Raman effect, which studied the scattering of light in liquids, solids, and gases. For this tremendous invention, he received the Nobel Prize for Physics in 1930. To celebrate this success, the government of India decided to celebrate the day on 28 February as National Science Day from 1999. So the first National Science Day of India was celebrated on 28 February 1999. As a part of celebration, the Department of Chemistry has conducted science quiz in the morning to generate curiosity about science. Total 481 students have attempted this quiz. May I now request our principal sir to give welcome speech. Please, sir.
Thank you, madam. Good afternoon, one and all. So first of all, I welcome our today's speaker, Dr. P.K. Khanna, ex-dean, DIT, Defense Institute of Advanced Technology and professor of the DIT, all the faculty members, the convener of this Science Day, head of the department, Dr. A.B. Pawar, all heads of department, my all faculty members, and dear students. Today, this is 27 February 2021, but 28 February is the National Science Day. So every year we can celebrate this day, that is National Day, on the day of 28th. But because of tomorrow there is a holiday, all the students, and that's why we are organized this day as a program one day before. Indians celebrate the National Science Day on 20 February every year. This day makes the discovery of Raman effect by Indian physicist Sir Chandrasekhar Venkata Raman on 28 February 1928. He was rewarded for Nobel Prize in Physics in 1930. Every year, Indians celebrate this day to widely spread a message about the importance to science using widely spread of message about the importance to science. And every Indians use this day for daily life of the peoples, as well as each year they have a specific theme for the National Day. This year, 2021 theme is History and Significance. So every year, each science person or each science student is very interested to do each and every activity. But today, because of COVID-19 pandemic, it is very unfortunately we cannot celebrate by preparing project, preparing in different type of themes by the students, and that's why so we are celebrating this day online with the different eminent scientists, so as to our student can listen and celebrate this day online. So in this view, I again welcome all the faculty members, especially our chief guest today's speaker, our friend Dr. P.K. Khanna, and all my dear students. Thank you. Thank you very much.
Thank you, sir. Am I audible?
Yes, ma'am. Yes, ma'am.
Yes, yes. Thank you, madam.
Thank you, sir. Now I would like to request Dr. A.B. Pawar, sir, to introduce today's chief guest, Dr. P.K. Khanna, sir. Please, sir.
Okay. Am I audible?
Yes, sir.
Yes.
Yes, sir.
Okay. Good afternoon, everyone. Speaker of today's web lecture, Professor Dr. P.K. Khanna, sir, renowned scientist and professor, Department of Applied Chemistry, Defense Advanced DIT, Defense Institute of Advanced Technology, Pune, in charge principal, Professor Dr. S.R. Patil, sir, my colleagues and dear students. On behalf of the Department of Chemistry of Yeshwantrao Mohite College, I, Dr. A.B. Pawar, Head Department of Chemistry, take this opportunity to welcome to you all in this celebration of National Science Day program. As we are aware that National Science Day is celebrated in India on 28th February. It is celebrated to commemorate invention of the Raman effect by Mr. Sir C.V. Raman. And he was awarded. Hello, am I audible?
Yes, yes.
Yes, sir.
He was awarded Nobel Prize in Physics in the year 1930. So we should have a respect, we should have a dignity to Sir C.V. Raman sir. In this regard, we have organized today's web lecture of Dr. P.K. Khanna sir. At the outset, I would like to introduce Professor Dr. P.K. Khanna sir in brief. Professor Dr. P.K. Khanna, he is a family member of Bharati Vidyapit. If you need any kind of help from him, he never says no. He's very kind, very friendly, and he has a helping nature. He has completed MSc PhD in chemistry. He has completed his MSc in chemistry from Bundelkhand University, Jhansi, UP in 1984. And after then, he did complete his PhD from IIT Mumbai in 1990. After completion of his PhD, he went to UK for postdoctoral research. He was there from 1990 to 1992. And after then, he joined as a scientist at CIMET Pune. He was there from 1995 to 2011. And since 2011, he has been working as a professor in the Department of Applied Chemistry, DIT Pune. He worked on many positions in DIT Pune, Chairman of IIC, Dean of Academic Affairs, Dean of Applied Chemistry, Member of Academic Council, and I think presently is working as a control of examination, DIT Pune. He has a significant or remarkable contribution in the field of research. He has published 260 plus research papers in reputed international and national journals and has attended 150 plus seminars, conferences, and workshops. Sir has delivered 100 plus talks at international and national level. He has guided 7 students for PhD, and Sir has completed 7 major research projects funded by DST and DRDO. He has published 15 patents. So this is the brief introduction of Professor Dr. P.K. Khanna sir. Sir, you accepted our invitation, and today virtually you are being with us. Once again, I welcome you, sir. Thank you. Thanks a lot.
Thank you, sir. Now I would like to request Dr. P.K. Khanna, sir, to deliver their speech. Please, sir.
Yeah, thank you very much. Can you see the screen? Hello?
Sir.
No,
No,
sir.
sir.
Yes,
Now?
sir. Screen is visible, sir. Yes, sir.
And am I audible also? Can you
Yes,
hear?
sir. Yes, sir.
Good.
Yes.
Thank you so
Yes,
much.
sir.
Thank you, Honorable Principal in charge of YM College, Dr. Pawar.
Khanna sir, you are not audible, sir.
This is a wonderful opportunity, and I'm very glad
Sir, your voice is breaking.
that YMC is celebrating
Sir,
the National Science Day. So it is always a pleasure to talk about science to the science. Yeah, okay. Let me see how we do. Is it okay now? Can you hear me now?
Yes, sir.
yes, sir. Yes, sir. Now okay.
Hello.
Okay, sir. Yes, sir. Okay now.
Now, I'm not keeping my video on because otherwise it will be too much of burden. And speak.
Okay, sir.
Good person. So there are some technical problems, it seems, from this side or that side or this side. Hello?
Hello. Yes, sir.
Yeah. Can you see?
Yes, sir. Yes, sir.
Okay. So thank you, YM College, for inviting me for such a wonderful occasion, on such a wonderful occasion to give a talk on, National Science Day. I will take you little briefly before we begin the achievements of Sir C.V. Raman. That why we celebrate National Science Day. Our inaugural speakers have mentioned that. But more than that is an opportunity for the students, those who are indulged in science practices or they're learning science, they get the chance to understand who has contributed and who has brought names to the country by doing fundamental sciences, basic sciences, and how important is basic science for the student to learn, so that many of them become scientists in future, and therefore more and more science discoveries can be done in India. Oftentimes we have seen that the students after 12th standard take a career path, they decide career. Someone wants to go into engineering, some wants to go into medical, and the science for the BSc and MSc. Those who end up doing BSc, MSc eventually become, take up a career in teaching and start practicing research. Not that the engineers and doctors don't do research, they also do research, but then their the nature of science becomes more applied and more of technology oriented. For basic things, BSc, MSc students today, I believe they are the audience, and it is good for them to understand how the basic science can be practiced and will. As I've been told to the student and audience that I practice chemistry. I'm a professor of chemistry and I practice nanomaterials and nanotechnology. So the last few slides of this presentation will take you how the Raman spectroscopy can be useful in nanotechnology, nanomaterials. So here I'll take you a little bit to the history of why we celebrate. In 1986, the National Council for Science and Technology Communication asked the government of India to designate 28 February as National Science Day. Before that, it was not there. In 1986, so many years prize was given to Sir C.V. Raman. This thought ferment and the scientists in the country that let us. The government had accepted this offer on 28th February as National Science Day in that year. And then the first National Science Day was celebrated on 1987, right? So it is not right from the beginning, and it is not so old. The 1987 and today is 21 is merely 13 plus. But in that 34 years, by virtue of celebration of National Science Day, millions of students got enthused, and they got into science understanding and importance of science, and then started practicing science and got more excitement in science by such kind of lecture and celebration. The theme of the National Science Day in each year has been decided by the community, and then this year happily is the National Science Day theme is the future of science and technology in India, impact on education, skills, and work. That is the theme this year we're given for celebration of National Science Day. It is celebrated on 28th February, that is true, but depending on the convenience and operation of the organization, sometime it happens on 26th, 27th, 1st of next day also perhaps can happen depending on what situation we are prevailing in. Today, in difficult time of pandemic, is sailing through nicely, taking care extremely well, wearing masks when we move out of the house, and practice all norms decided by the government, structured by the government, to keep the pandemic away, and get ready for the real learning when the school, college reopen, and that is possible only when we practice a lot of precaution in this difficult time. But this difficult time has given you to see the wonders of science, that you are listening this lecture and attending this function while you may be sitting at home. We never thought of that before the pandemic, although it was well within our hand. We were knowing that the video calling can be done. We knew that emails are happening. Google Meet is there. So many other platforms, Skype was there. But we never tried to practice so seriously because that was not needed. It was known to us, and for some purpose we were using. But today, and our pandemic fear, country has to move, institute has to move, your life has to move, families have to move, so everything has to move, and the show must go on, as they say in English. There is a phrase, "So must go on." So has to go on, irrespective of pandemic, and all the students, all faculty, all scientists, and the public in general has learned how to live and started calling a new normal. Loss of sessions, there is no loss of school, college, lecturing, and all. Students, the young age students, 16 years into online lecturing. Government has come up with so much of learning, classes given on teachers, and then they are integrating to the students. Today, that has Resilience Day, which used to be otherwise a mass celebration in the campus, in the colleges, in the institute, and where hundreds of students will be attending the physical lecture in physical form, or attending lecture online through YouTube or video recording or Google Meet and Zoom and all. So thanks to, in the country is also very, very efficient. Of course, some teething problems here and there, time to time happen, but by and large, we have been able to meet the, desired level of expectation of student, parents, and teachers. The initial struggle for the teachers and students both have now been settled, and the last last 6 months definitely in the right direction. So the net result of that is that today we are celebrating National Science Day virtually in almost every place, I guess. Let us move further, and I will focus a little bit on Sir C.V. Raman's life, which we have gathered from the internet, understanding ourselves, how beautifully he moved on in Sir Chandrasekhar Venkataraman, as he is full name, popularly known as 1888. This is not me telling, it is the documented fact. I've gathered it from the resources. His father's name was R. Chandrasekhar Iyer Amai. Now you see this, the house of Sir C.V. Raman. This was the house where he was living, and have gathered from the internet to make the student understand that you may be living in a small house. We all live in a small house, and then slowly we work hard and study well, and then eventually reach to certain heights. So this is also one of the examples that Sir Raman also was having a modest living. Those days, of course, these houses were considered big houses. But look at this. This is the traditional house where Raman sir was living. Right? Now, what happened to his education? He was a very hardworking, very brilliant student, and early education was taken in St. Aloysius High School. That in Visakhapatnam, he completed his early education. After that, he did his BA from Presidency College in Madras. So if you will Google through, you will find a lot of things from Sir Ram, 1900. Today we are in 2021. So imagine 100, and today we are talking about him. So I feel this is very motivational to all the students, that you are being taught after hundreds of years after you have lived. And that kind of motivation you should keep as a student, that I should do something in life, that it will leave an impact and people will remember me. So Sir C.V. Raman was similar personality. He did something, great, and that is why today we are remembering him and celebrating National Science Day. He did his MA in Presidency College, Madras in 1907, and obtained highest distinction. In BA, those days it used to be BA and MA. I can correlate that because in Oxford University, also a BA and MA degree is given through science. So since India was under the British rule, perhaps that kind of terminology and nomenclature must have been there in our educational system. So he was a gold medalist in his bachelor, and then he was having a distinction, in MA. And then what happened? He continued practicing physics.
Sir, sorry
Many
to
people
interrupt you.
will
Sir, Sir, sorry to interrupt you. Your voice is breaking, sir. Hello, sir.
Yes.
Sorry, your voice is breaking, sir.
Yeah, I think that suits. Sometime
Yeah. It is breaking, sir. Sometime it is breaking, sometime it's okay.
Hold on.
Screen is okay, sir. Screen is not having any problem, sir.
Is it possible?
Screen is okay. Your voice is breaking, sir. Screen is okay, no problem for screen. Hello, sir.
You may have to reconnect in that situation.
I think, sir.
I will reconnect.
Okay, sir.
Are you able to hear now?
Yes, sir. I'm able to hear now. No problem now.
I am reconnecting.
I will reconnect it again, and then start.
No, sir, now your voice is
Give me a-
clear, sir. Now voice is clear.
Okay, so let me continue.
Yes, sir. Yes, sir, please. Thank you, sir.
Yeah, okay. So after doing his MA, he continued practicing physics. Am I advised? Yeah.
Yes, sir. Yes, sir.
And then in 1907, he was offered the position of a Pilot Chair of Physics as professor at Indian Institute of Science in Bangalore. You see, in 1917, he became professor at IISc Bangalore, very famous institute. You know, that the students should realize that is existing since then. It is such an old and prestigious institute where Sir Raman was a professor. And then he was sponsored the establishment of Indian Academy of Sciences. You know, Sir Raman sponsored that, okay, let me establish Indian Academy of Sciences, right? Perhaps he was involved or he proposed something prestigious body today. He was given various awards, like 3 awards which I have mentioned here. You know, Mastercy Medal, then Hughes Medal, they were European awards, and the most prestigious, the Nobel Prize in Physics in 1930. And that is why he is known as, you know, Sir C.V. Raman, because we are celebrating his findings, because he got the Nobel Prize in that. You know, some of his other achievements which are documented, well documented, he was elected as a Fellow of Royal Society in 19, you know, knighthood by British government, which is how it is called Sir, in 1929. Right? There is a very big tradition in British Empire that they will honor the people, and they say that knighted. So somebody will be say after they are knighted, they will be called Sir. So Sir Dr. C.V. Raman became Sir C.V. Raman in 1929. You see, he was having various fellowship of the Royal, I know, for some technical reasons. Right? He was, you know, it is documented that he was the only person who has done that. Fellow of Royal Society is such a prestigious, you know, association and recognition, but he resigned in 1968. So scientists have their own mindset. They work very hard. When sometimes they are not convinced with certain things, they do not compromise. So what it says that highest level of values are practiced. Are you able to hear?
Yes, sir.
Okay. So this is very, very, you know, crucial point to understand. Sir C.V. being a very great scientist, he did not worry about his, because of certain technical issues, he resigned that. Fellowship, give me this, I get more recognition. You see, that's such a person, he said that, okay, stick to it. So the good quality scientist will always have those, you know, things in mind. So he resigned. Then in 1930, he won a Nobel Prize in Physics. In 1941, he was awarded the Franklin Medal. You know, once you are highly recognized, a lot of people will definitely recognize you more, and therefore good work will always be valued by many societies across the globe. In 1954, Government of India awarded Bharat Ratna to Sir C.V. Raman. So he was, you know, Bharat Ratna of India. So we can proudly He was awarded Lenin Peace Prize in 1907. Some debate, society, some discussion, some meetings will take place time to time. So one such meeting, jointly the American Chemical Society and Indian Association of Cultivation of Sciences recognize the international historic chemical landmark. That is what they say was the Raman effect and Raman discovery. So what was all about? Sir C.V. Raman is famous. Sir C.V. Raman was a great scientist. So what he did? Let me take you in very simple concept what Sir C.V. Raman did. You know, actually, you have to understand the BSc, MSc student, little bit of fundamental physics and little bit of fundamental chemistry. Maybe it is documented in your books already, but here is something which is in the simplest manner, little bit pictorial. It will be easy for you perhaps to understand. A.H. Crompton, a scientist, had shown that the nature of X-ray changes when passed through a matter. Suppose the X-ray are passing through something, that the nature of X-ray will change. The change was dependent on the kind of matter. Means the change will be based on through which it passes. This effect was called as Crompton effect, for which Crompton was given the Nobel Prize in Physics in 1927. You see, it all started from there. So Raman effect was not just directly, but it got associated with Crompton effect, because he proposed there will be change in X-ray if you pass with different objects. Now, this means Raman started asking himself, based on that Nobel Prize of 1927, that could light also change the nature? The X-rays are different, but could the light also change the nature when passed through a transparent medium? This thought came in the mind of Raman. So there was a question, and that Raman asked himself before asking anybody. So he said, okay, let me think why and how that will be possible. And that is how his journey started. So I can perhaps correlate that the 1927 Crompton Nobel Prize triggered a thought process in the mind of Sir C.V. Raman. That what about normal light changing behavior? So for the next 5 years, he had been doing research in optics. Optics, the lenses and all kind of material devices through which the light will pass and it get absorbed or reflected and all. So he was practicing the research in optics and the science of light. So that is how he was very close to his thinking, and then thought that, okay, let me do some experiment and then try to understand whether what he's thinking is correct or not. Those days, there was no sophisticated equipment. And they were not available to his laboratory, but Raman sir was very confident that he could find the answer with some modification in the equipment. So he has some lenses, he has some light, directional. So something he did, and then eventually what he said, 4 months later, on March 16, 1928, Sir Raman announced his discovery of new radiation. He was thinking he has some basic equipment, and then 4 months continuously, 5 months he was doing something, and then after 5 months he announced that new radiation has come. Whatever he practiced and experimented, he said the behavior of beam of light passing through the liquid chemical, right, to an assembly of scientists in Bangalore. He said that the new radiation he could observe when the light passes through the liquid chemical. Now in Bangalore, there must have been some meeting those days. So he discussed among the scientists in Bangalore. And this picture you will see. So what I can say that his experiment initially were directed that yes, there is a liquid chemical, and if I pass some light through the liquid chemical, the behavior of light is changing. So that he found that it is a new kind of radiation, which was not earlier observed by others or anybody. So that he shared with many of his friends in or scientists in Bangalore. So the first instrument which was used by Raman sir is shown here on the left side, if you will see, and the right side below in the picture, he is seen with some of his colleagues and students discussing about the effect. This is how the basic laboratories were there those days, 100 years, 90 years ago, 100 years ago. Now, the world then came to know, the whole world came to know what discovery Raman sir has done. The world hailed the discovery as Raman effect, because nobody has earlier thought of this kind of, study and behavior of light. So when the people came to know that, oh, this is something, a new radiation, so they gave the name of that to that radiation as a Raman effect. This is such a great honor for a scientist that when his name is associated with some, discovery and effect and, behavior of material or light or any kind of a study. So Raman effect for scientific research in this country, it was a sort of a red letter day. This is an English phrase that is the greatest achievement for an Indian people. And everybody was proud of something. It is, such a great honor. So his discovery caught the attention of the whole world, because that is how it is. When any science discovery is done, even today, nowadays, when you will hear the Nobel Prize is given to such and such person, so a lot of students, a lot of scientists, they all feel excited, because ultimately when you practice science and technology, you look for that what new thing has come and how excitingly that will serve society. So everybody is happy for achievement. So same thing happened to Raman sir, and he was celebrated. These pictures shows that Raman scattering, the effect of light, passing through the solid, passing through the liquid. So these are some pictorials, right? You see, in 2013, the Raman effect has been designated as an international historic landmark by American Chemical Society. You see, in 1998, they discussed about it, but American international, historic chemical landmark was now tagged as Raman effect by American Chemical Society as recently as 2013, because they are not able to forget such a great contribution, and time and again people would like to talk about Raman and make sure that it is directly relevant to the today's science and technology studies. Now, what is Raman effect in general then? Sir C.V. Raman used heavily filtered sunlight, sunlight which is falling from sky, so-called sunlight which we have, we see the scattered light. So he developed some kind of a filter and placed on a laser and observed that the energy change between the initial energy and the emitted energy, there is an energy change. So the initial energy and then emission of energy. So that change was observed, and in the C.V. Raman effect. Eventually, he says a light scattering technique to produce scattered radiation of varying wavelength in terms as Raman spectroscope. So what is that? Sunlight falling on something. Sunlight is photon. So when the sunlight is falling, that means photons are falling, right? The photon will interact with something and then produce a scattered radiation, which is what is Raman spectroscope. It allows the scientist and researcher to obtain vibrational spectra in a given solution. So when you have a liquid chemical, if this light will pass through, a photon will interact, you will see the vibration in the bond of the chemical. So that is how the Raman spectroscopy becomes, Raman effect becomes useful. And eventually, this is measured in terms of spectroscopy. And finally, you will see Raman spectroscopy has been practiced in the last several decades very heavily. So how all that happens? You see the sequence of event in Raman effect discovery. On 16th February 1928, he posted a note to Nature. Nature is a very big journal. So Raman sir decided that let me write my discovery to Nature journal. Right? So where to publish, how to tell people. So world should know. So there are various platforms, various journals, various magazines. So the children, those who are doing BSc and MSc should know the journal importance. When you publish something, it will reach to people. So Nature is such one journal, and those days, obviously even today, that is one of the best journals in the world, publishing fundamental science discovery, and nowadays applied elsewhere. The modified radiation could arise from the fluctuation of molecule from normal state. He wrote that one small note to Nature, saying that such thing can happen. So on 28th February, the spectroscopy shows that the track contains not only the incident color, but at least another separated by a dark space. So he also found that there are some changes in the light which was passing. On 29th February, the discovery was announced to the Associated Press that yes, there is a change in behavior of light. So then what happened? On 8th March, he sent a note to Nature that Raman and Krishnan, the note which he sent to Nature was rejected by the referee. This is such an interesting, story for the students, that the greatest of discovery which was produced by Raman sir was basically rejected by some of the referees, right? But it was so impactful, perhaps, but the editor of the journal published it. He said, yes, I'll publish. It is great. Perhaps that could have been happened, right? So there is a gist here. You see, I have got it from, internet only. There is one, note on some kind of an article, first page, given by Raman sir. This was published, a new radiation by Sir C.V. Raman in Indian Journal of Physics in March 1928. What it says, Raman sir says, I propose this evening to speak to you on a new kind of radiation or light emission. You see, the introduction of the article itself says, I propose this evening to speak to you on a new kind of radiation or light emission from atoms and molecules. Nowadays, we don't write like this. Nowadays, we write like that, okay, we hereby propose that such a thing can happen. Those days, that was the kind of confidence it shows, that yes, I have got something to tell to the world. So that is why he mentioned this, I propose, with a lot of authority. To make the significance of the discovery clear, he says, I propose to place before you the history of the investigation made at Calcutta. He was serving with Calcutta, in Calcutta, which led up to this Raman effect discovery. Then he said, before doing so, however, a few preliminary remarks regarding radiation from atoms and molecules will not be out of place. So this is what he wrote in the first page. And he says various ways are known to the physicists by which atoms or molecule may be caused to emit light, as for instance, heating a substance or bombarding it with a stream of electrons. The light thus emitted is usually characteristic of the atom and molecule and is referred to a primary radiation. He knew that primary radiation by heating can be done. But it is also possible to induce radiation from atoms and molecules by illuminating them strongly. So that becomes another type of such light emission is referred as a secondary radiation. So he came up with this kind of terminology analysis and says familiar diffusion of light by rough surfaces may be cited as an example of secondary radiation. So like that, he published his work in Indian Journal of Physics. So a lot of study, he was a great researcher, and you see importance contributor are Sir Raman. I made a table here. The essence of science, he said, is independent thinking and hard work, not the equipment. You see, a lot of time we do research and we think that, okay, if I have that machine, I can do research better. If I have another machine, I can do much better. But during the Raman sir time, the equipments were not so much available. But his thinking and his philosophy and his belief that I can prove it. Those were the days when people were doing a lot of assembly by themselves and fixing the small items, whatever was available to them, and creating new tools. So he was believer in that independent thinking and hard work, not the equipment. Equipment you can build, but first you have to start thinking in that direction. So that was a great thing about Sir Raman. So what he did, many inventions he did, I have cited them in the left, like blue color of the sea water, discovery of Raman effect, Raman and Nath theory, then discovery of soft mode, then other contribution, optical and magnetic and isotropic, acoustic, Indian classical music, he was also there, then crystal dynamics, then physiology of color and vision. Many discoveries he did. And his famous publications, you see, molecular diffraction of light, mechanical theory of bowed string and diffraction of X-rays, theory of music and instrument, the physics of crystals, more than 500 original paper he contributed those days. Such a great scientist he was. Now, this should enthuse our students to think like Raman sir. Okay. So another good thing, with equipments worth hardly rupees 200 and limited facilities, Raman was able to make a discovery which won him the Nobel Prize in Physics in 1930. What is the cost of equipment? 200 rupees. Of course, in 1920, 200 is a big money, but not so big. The equipment is not possible in 200 rupees those days also. The equipment nowadays costing in crores and crores. The 200 rupees there also you can buy only small things. Today, when you talk about 200, is nothing. So what it says that with a small money, if your thinking is big and your philosophy and principles are in right place, and your science is right place, you can achieve something. So this is motivational to students, that never think that, oh, big things only required to do big research. Big thinking is required to do big research. Now, this shows the Nobel Prize in Physics was given to Raman sir in 1930. This is some of the glimpses I will see. The molecular scattering of light. He wrote some, paper here. One block is showing that. What it says, as Raman effect. In his honor, various medals were printed, various stamps were printed by our government of India. Sir Raman was that great scientist. Now, what is the importance of Raman effect? Now, let us talk a little bit how you as a student and you as a scientist can practice it. Sir Raman gave something and the whole world got excited, whole world got so when the molecule vibrates, it gives, it can be used to examine rotational and vibrational states of the system. So how this will behave under the impact of certain molecules. So this is very important because a lot of chemicals we are using, a lot of things are associated with chemistry and physics. So unless we know the behavior of chemical, how will you understand its reaction with something else, how it will behave with another molecule. So all that is required for any researcher and student. It gives you number, strength, and identity of chemical bonds. Unless these are known, it is not possible for any researcher to start conducting research. These are very basic things to be known to the researcher when you begin. The application in real life, the identity of molecule. So when you are using certain chemicals in your daily life, know the of the molecule. As a literate person, educated person, we will be better equipped to use it. We will be happy to use because we know about the molecule. Then it will also give you environmental monitoring. In the environment nowadays, a lot of pollution is there, a lot of molecules are there, gases are there, and they are polluting the environment. So by Raman spectroscopy, when I believe this will be possible to monitor what gases through the same property, vibrational strength, and understanding the rotation. Then it can also help in explosive detections, a kind of research that explosive detection can be done by Raman spectroscope. Similarly, quality control in the industry, commercial industry can use it by developing some signature, by doing some. Then biochemistry, medical application, everywhere I use. And therefore, it is going to be useful irrespective of the industry. In electronics and in semiconductor also, because one can get you. Here is one when it is used for cancer cell detection. Some people have reported that the Raman spectroscopy can be useful in detection of cancer cells. So here is some picture where people will inject the nanoparticle and then they will pass through the various stages, and then when the laser light is falling on them, then there is some Raman signal coming. So people have in nanotechnology. So what is nanotechnology for my audience? Is the study of material which has dimension less than 100 nanometer. Nowadays, nanotechnology is everywhere in this world. The surface to volume ratio has increased. Nanoparticles, because of the high energy and are very, very reactive, active, and their properties enhance tremendously. Whether chemical property, whether optical property, whether mechanical property, thermal behavior, everything becomes very, very enhanced. So once they are having such enhanced properties, they are able to provide you new applications, new utilization, new technologies. And therefore, nanotechnology has become very, very, useful in today's time and very advanced nowadays. Now, Raman spectroscopy major role in development of nanotechnology. Now, who could have believed that 100 years ago? But today, the discovery made by Raman 100 years ago is playing the greatest role in nanotechnology to make the scientist's life easier, to make scientist's life more exciting, and make students learn how the physics, chemistry, biology coming together and making impact in social, life. So here is Raman spectroscopy. It gives you Raman spectroscopy. It is not just, you see the light and end. They created the machine out of it. Spectroscopy is an inelastic scattering phenomena. The probes molecular vibration to provide a molecular fingerprint of material. That is what is the Raman spectroscopy in simplest manner. The 6 major types of Raman spectroscopy are under use today: spontaneous Raman spectroscopy, resonance Raman spectroscopy, coherent anti-Stokes Raman spectroscopy, stimulated Raman spectroscopy, then spatially offset Raman spectroscopy. So very way they can utilize it. They came up with the new terminology. Okay, this is how. So in nutshell, what it is required to understand: what is Raman effect, how it can become a spectroscopy, and how the nanotechnology has utilized it. What is Raman spectrum? Generally measured in wave number, just like infrared spectrometer. The wave number. The wave number is represented by number of waves per unit length in centimeter inward, which is given by the below formula. Now these BSc level, 12th standard BSc level, MSc level formula. So students will be happy to know that how small formula is useful for making advancement in science and technology. It is summarizing everything into this formula. The wave number is equal to mu by c by n is equal to 1 by lambda. You see, where lambda is the wavelength and mu is the frequency, c is the speed of light, and n is the refractive index. Now these are the factors which are affecting your life through the Raman spectroscope. It is that basic. Now there are how the light scattering will take, anti-Stokes lines will come. So all that is the Raman spectroscopy, which will be taking finally into the consideration for analysis, for broader understanding. Now, coming to the nanomaterial, how that is useful, the Raman spectroscopy can be used as a tool to identify nanoparticles and the nanostructure material. So each nanoparticle has, millions. So in the bulk material, there are billions of atoms. Nanoparticle, the number of atoms reduce, size reduce, and therefore it is likely that the impact of the light will also be having some alteration or some effect on that. So amorphous or crystalline phases can be understood by Raman effect, Raman spectroscopy. Suppose some material is amorphous and some material is crystalline. So when the Raman analysis will be done, there will be difference. It can also be useful for determination of size, particle size, diameter, and lateral dimensions. Then Raman spectroscopy is also useful in uniformity, homogeneous, and dispersion. Shape of the nanomaterial. Suppose it is the rod shape, spherical, wire. It can differentiate between allotropes and of the same material. So different types can be useful for analysis can be done of the nanomaterial. There is a very famous one which is known as surface enhanced Raman spectroscopy. In the nanomaterial, this is very advanced technology and moving with a very rapid pace, and a lot of people are working on that. So which is known as SERS. SERS uses metallic nanoparticle deposited on the surface of a nanomaterial to enhance the Raman signal of the bond or atoms in the nanomaterial by significant amount. You know, something is not giving you good intensity. If you have put some nanoparticle into it, the intensity of the molecule or that atom, the signal increases manifold. So this is possible by Raman spectroscope. And once the intensity is manifold, you will understand the nature of that material or chemical. This technique is useful for ultra thin nanomaterial, which does not exhibit the highest signal intensity. You know, this SERS can be useful for very thin nanomaterial. Generally used with SERS is very useful for bio-nanomaterial. It is less destructive than other. So with these kind of things are possible, and I have to show you this picture, where in this picture one can see the gold or silver nano put on the surface, and because of that, you know, Raman scatters, and that helps people to behavior of that molecule. Now here is semiconductor nanoparticle, metal sulfide, molybdenum sulfide. Now this picture shows that two figures, one is a black one and another is in the red one. The red one is the bulk molecules in the micrometer size. And two peaks are there. One is at 300, another is at 400 centimeters inwards. But when this is the bulk material, but if that converted to a layer, a thin layer form in the nanostructure layer, the intensity of this peak is tremendously enhanced. Now monolayer by Raman spectroscopy. Suppose you have been given the material and you have been asked to prove whether it is bulk or it is monolayer. You will record this spectrum and then tell that yes, it is monolayer or it is a bulk. By looking at the picture, one can be able to comment. Why all that happens, that I told in the beginning, it happened because of certain vibrational and rotational behavior. Identification of number of layers is possible. How many layers are there in a given material? Thin film, suppose. Here are the typical example of two semiconductor. One is molybdenum sulfide, another is molybdenum selenide. So sulfide, you can see there is a peak position between the bulk and few layer are dotted. Blue layer is the dotted ones, red one. When it is a single layer, the Raman shift is different, and when there are number of layers is increasing, the Raman shift is changing. So this is how one can, whether it is single layer or multiple layer. One, it is very important important for a student to understand between Raman spectroscopy and spectroscopy. Because centimeter inverse. So there is some difference. What happens in Raman? IR depends on the change in the dipole moment. So students should keep in mind when this is a typical examination question. Often in exam it is asked, what is the difference between Raman and FTIR? So please note that students measure relative frequency at which sample scatters radiation. That is happens in Raman. What does it do? Relative frequencies. But FTIR does absolute frequency measurement. Raman does relative frequency measurement. It does absolute. And then Raman does, it is sensitive to homonuclear molecular bond. For example, carbon-carbon bond, carbon-carbon double bond, carbon-carbon triple bond. And in FTIR, it is sensitive to heteronuclear functional groups vibration, polar bonds. There's a difference, you know. So this difference is to be understood by a student because they are same but not the same. They give the vibration and rotation information, but there is a difference within that. Now I'm moving. Are you able to still hear me? Hello.
Yes, sir.
Yes, sir.
We are able to hear you, sir.
My internet is a problem. Okay, hearing. My slide movement is very slow because it is getting downloaded parallelly. So it is. I think I have come to almost an end slide, which I wanted to show you, and then that slide I will continue another. So in today, while the slide is getting loaded, I will continue to speak about Sir Raman. That yes, it is a wonderful opportunity for science students to indulge in the spectroscopy and through the life of Sir C.V. Raman to understand how, with a modest beginning, you can become great scientist and make a difference in the society, and you can contribute in science. So with this, I think I will conclude. And there is a big event coming up in DIIT. In DIIT, we are having a big conference on 24th and 25th March, which is basically on fundamental science of nanoscience, talking about chemistry of materials. And there many people will talk about Raman. Now this slide which has come just now, you can see. Can you see this slide?
Yes, sir.
Yes, sir.
This slide tells you in DIIT on 24th, 25th March. So I will request all the participants in lecture, please try to register for it and attend online lectures, which are 16 numbers, and they are top scientists of the country. Many of them will be talking about Raman spectroscopy also for nanostructured material. Otherwise, the name chalcogenide. There will be good insight and teaching about nanoscience and nanotechnology by 16 speakers. They will have a specific example for chalcogen compound, for example, CDS, ZNS, zinc oxide also. But the knowledge you will gain through the lecture will be tremendous. So I appeal and I advise, take advantage of such a wonderful event which is coming next month. Okay. This is of my research group which work with me time to time, not at one time, but over a year we have trained. YM College, and thank you Bharti Vidyapeeth banner for continued association. I'm always happy to support your cause in research and science. Thank you very much.
Thank you, Khanna sir, for giving a valuable speech about history of Raman effect. This session is open for question and answer. I request all the audience to ask questions.
I can ask question myself first. The question is, yes, I am available. Also, I am available on email. So if some of the students feel hesitant or any reservation or any difficulty, they can post me the question by email, and I will be happy to answer those questions, even not today, throughout the year, anytime. So not to worry and don't hesitate, but you are welcome to ask.
Thank you, sir. May I now request Dr. M.P. Wadekar to deliver vote of thanks. Madam, please.
Okay. Hello, am I audible?
Yes, madam.
Okay. Thank you also, madam. Respected dignitaries, teachers, and students, I, Dr. Mrudula Wadekar, am here to propose vote of thanks on the behalf of YM College. First of all, I would like to thank our principal, Honorable Dr. S.R. Patil sir, who has motivated us to organize this lecture on the occasion of Science Day. Thank you, sir, for your guidance and for making available all the facilities for organizing this lecture. I express my deep sense of gratitude towards today's honorable speaker and great scientist, Dr. P.K. Khanna sir, professor at Defense Institute of Advanced Technology, Pune, for accepting our invitation for delivering the lecture and guiding our students. We are lucky enough to have such a renowned personality with us today who always guide and motivates us to do excellent quality research. Sir has highlighted importance of basic sciences in the field of research. Also, he have explained the scientific journey of Dr. C.V. Raman sir and has explained the Raman effect and its importance, its applications very nicely in simple language. Thank you very much, sir, for sharing your valuable thoughts and enlightening our students. I take this opportunity to thank to head of the Department of Chemistry, Dr. A.B. Pawar sir, for his encouragement and support for organizing this program. I extend my thanks to convener of today's program, Dr. Sharda Gadale, for her sincere efforts taken for the celebration of Science Day. I am equally thankful to Dr. V.B. Jadhav sir, Dr. V.B. Adsu, and Dr. A.S. Kadam for their help. I am also grateful towards V.V. Adsu sir, Vice Principal, Junior College, for his cooperation. I express my sincere thanks towards all heads of the departments, all teaching faculty from senior as well as junior college who have helped by heart for making successful this Science Day celebration program. I am thankful to Dr. Mrs. V.B. Adsul for nice comparing and taking efforts for making science quiz along with me. I thank Dr. Mrs. S.S. Pawar for her useful suggestions for the quiz. I also would like to give special thanks to Dr. Omkar Gurav sir for his technical help. Uh, I also thank uh, all the students who have attempted the quiz in large number and have patiently listened the lecture. So I thank all of you, and now we have come to the end of the program. So with the permission of principal sir and everybody, I will say that the program has concluded. Thank you everybody for attending.
Okay. Thank you, Khanna sir.
Okay, thank you, sir. Sir,
Thank you, sir.
Thank you, Khanna sir.
shall I end the meeting?
Yeah.
Yes, madam.
Okay. Thank you, sir.
Okay. Thank you, sir.